All right, so let's look at a very simple quadratic equation that can be easily solved using the square root property. So for example, if I want to solve x squared, let's put this number 1, x squared equal 25, you can actually look at that by inspection and tell me what the solutions are. What are they? 5 and negative 5. Because x squared means x times x, correct? So what times itself is 25?
5.
Well, 5 times, well, 5, because 5 plus 5 is 25, and negative 5. So when you did that last semester, you saw that your solutions would be, in this case, they would be x equal 5 and x equal negative 5, right? But then you had the discussion, well, the idea is to solve for the variable x. Right now I have x squared. What am I doing to that variable x? Squaring it. Your discussion in the past was, well, what's the opposite of squaring? Square root. Opposite of squaring is square root. So what you did at this point was you did this. You said, I'm going to go off to the side and do this. You said, I'm going to take the square root of both sides. So remember, what you do one side, if you do an operation one side, you got to do it to the other side as well. And then the discussion was, well, the square and the square root undo each other. So you get x. So basically what happened was you would sometimes see this just to indicate that the square and the square root undo each other, and you left with what's under the radical, which is x, equal. But the square root of 25, though, that's a principal square root if nothing else is there. That's just 5. But what are your solutions? 5 and negative 5. So then at that point, that's where you were told, well, my solutions are positive and negative 5, so that's where you do that plus or minus. All right, so when you take the square root of both sides, just remember you got to do that plus or minus right here. Plus or minus. So it'll be plus or minus 5. And so on the blank, you can write as plus or minus 5, or in my math lab, it would say separate solutions using a comma, so you would actually have to say 5 comma negative 5. So then that takes us to a generalization, though, about this idea. So for example, number 2, I'm not going to do that just yet, but number 2, suppose we had this. 6x minus 5 squared equal negative 81. Now that you can't guess at the answer by inspection like we did in number 1. So there's some work you got to do there. So the generalization, though, is this. Now, the square root property, if you're going to use the square root property, if you're going to take the square root of both sides, it's got to look like this. So you got to have some expression squared equal a number, a constant. A constant has to be on the other side. So what? 6x minus 5 squared. So it's got to be in this form. Some expression raised to what power? Second, equal, and what must be on the other side? A constant, a number. No variable expression, a constant. So number 2 is number 2 in that form. Yeah, so once it looks like this, then you can take the square root of both sides, but don't forget I must also write over here what? Plus or minus. All right, so is number 2 in the form where I can use the square root property? Yes. So at this point, you're going to take the square root of both sides. And let me go ahead and rewrite this. So notice I did leave some space here. So you're going to say square root. What am I missing? Plus or minus. And then, so remember the opposite of squaring is square roots. That's why we took the square root of both sides. So the square and the square root undo each other. They're inverse operations. So basically what's left is what was inside the parentheses. What's inside the parentheses? 6x minus 5 equal plus or minus. And based on our discussion today in last class period, what is the square root of negative 81? 9i. All right, so that's where we're at. Okay? Now at that point, you're trying to get x by itself, the variable x, right? Okay, so out of curiosity, if I just had this, if I had 6x minus 5 equal, let's say 9, what would you do? Add 5 to both sides. Then what would you do? Divide by 6, right? Well, that's the same idea with that. All right, so let's talk about how to deal with this. So the first thing you're going to do is bring the negative 5 to the other side and then divide by 6. So I'm going to add 5 to both sides, actually write it out, just like this. Now let me tell you some errors that some of you are going to make. So you did that part, so I'm using the addition property of equality. But remember, you got to combine like terms. So the reason why here, when I added 5 to both sides, right here, and I said 6x was equal to 14, that's because 9 and 5 were like terms. But when I look at 9i and 5, are those like terms? No, they're not like terms. So don't say that is 14i. So what you're going to do is, and also remember that's plus and minus, that plus and minus goes with the 9i, right? Does not go with the negative, with the 5, it goes with the 9i. So what you got to do at this point is you got to say, well, 6x is going to equal 5 plus or minus 9i. That's what needs to go there. Those are not like terms. So you have two things. You have two terms here. You have a plus or minus 9i and a what? 5. We tend to put the plus or minus at the end, just like with the square root, with the quadratic form. Remember quadratic form is plus or minus the square root? It's always at the end of the numerator. Same thing here. And then finally, all you do is what? Divide by 6. Divide by 6. And so 6 divided by 6 is 1. 1 times x is x. And you can leave your answer like this. 5 plus or minus 9i divided by 6. Now 5, 9, and 6, remember that in terms of, like we did with the quadratic formula, if I look at those three numbers, 5, 9, and 6, the GCF is 1. But sometimes the directions, my math lab may say this. My math lab may say, write in the form A plus or minus BI. So I'm just kind of just mentioning what to do there. If it says this, if it says write in the form plus or minus BI, if it says that, basically all they want you to do is to write these as two separate fractions. So you'd say 5 divided by 6 plus or minus 9i divided by 6. That's what that would mean. But you can leave your answer like this on the worksheet. If it says write in the form a plus minus bi, then just write two fractions. So you'd say 5 divided by 6 plus or minus 9i divided by 6. Now, Math Lab, they may accept that. If it doesn't, then the reason they did not, if they use the word simplify, is because you didn't simplify 9/6. So what's 9/6 reduced? 3/2. Okay. All right. So just notice the different ways of writing the answers. All right. But this one's fine. Just remember, if it says a plus or minus bi, break down to two fractions. If you can reduce, because the math lab will probably say simplify. All right. Let's do number 3. So in number 3, let's suppose we had this. Three times x minus 5 squared minus 12 equals 0. Okay, so listen carefully with this. So sometimes the directions will say use method of your choice. And I'll explain what else you could do here if there's a direction. Sometimes the directions will say use the square root property. If it says use the square root property, you can't use anything else. Okay? And that word you're going to get will say use the square root property. So, if I'm going to use the square root property, remember it's got to look like what form? Some expression squared equal a number. So basically on the left side, you got to have what's in parentheses being squared, the only thing that's on the left side. Is that what I have here? No. Okay? So that negative 12, I've got to first of all bring to the other side. So let's do that first. What? That's a 5. Okay, so that's where I'm at. Now here's an error some of you are going to make. I'm just going to see if you say this at this point. What can you do next? Okay. What else could someone have said? Distribute? Okay. No. You cannot distribute here. Because remember, when you do the distributive property, I want you to remember this. When you do distributive property, the distributive property only applied with something like this. That I can do the distributive property with. You would say that's going to be 2 times 3x is 6x. And then 3 times a negative 7 is a negative 21. So yes, in this case, I can use the distributive property that I'm pointing to. But if I had this, 3 times 2x minus 7 squared. So some of you said do the distributive property, right? Okay, let's do that and see what happens. If I do the distributive property, I get 3 times 2x is 6x, and then minus 21, and that's being squared, right? Y'all agree? Well, let's go ahead and square this binomial and see what we get. So let's use the fall method. Let's use the fall method. Now you're going to need your calculator. You're going to help me with this. So 6x minus 21 times itself. What's 6x times 6x, the first? 36x squared. What's the outer? Use your calculator. 6 times 21. 126, is that right? And the inner is also the same thing because you're squaring the same binomial. And then what's the negative 21 times the negative 21? 441. Okay. And so this becomes 36x squared minus 252x plus 441. Okay? Now let's do this first. Let's see what happens if I square first and then multiply by 3. So if I can distribute here, then that answer better be the same as what I'm about to do. All right? So in other words, what I'm saying is this. Let's square first and then multiply by 3. See if we get the same thing. So 2x minus 7 times 2x minus 7. What's 2x times 2x? 4x squared. What's the outer? Minus 14x, and so is the inner. And then what's the last? 49. Okay. Combine like terms. I get 4x squared minus 28x plus 49. So that's just this, right? But that's being multiplied by 3. And if I distribute, do I get the same thing? No. So something's wrong. Something's wrong. So my question was this. Can I distribute first? No. The distributive property only applies is if what's inside the parentheses is being raised to what power? The first. Because remember the order of operations? Please excuse my dear Aunt Sally.
Yes.
So I'm going to ask you this. I'm going to ask you this. So you see what I have right here? This says I'm squaring and then multiplying by 3. According to your order of operations, you do exponents before you do what? Multiplication. All right. So this distributing property is not what you do first. Okay? So let's go back to our problem now. I think I kind of lost it. Where did it go? Oh, there it is. All right, so at this point, so I know I can't use distributive properties, so don't make a mistake because I'm squaring. Okay, distributive property only applies if what's inside that parentheses is being raised to the first power. So I got to make it look like that form though. Some expression squared equal number. So that means I got to remove that factor of 3. So what's the next step? Divide by 3. And now 3 into 3 is 1, right? So I get x minus 5 squared equal 4. So that's where I'm at. Now what's the next step? Square root. Take the square root of both sides. So you got to show that though. You got to show the square root being you taking the square root of both sides, not just the left, not just the right. Mathematically, it must be both sides. So I'm just going to go ahead and rewrite this over. So you got to say this, and then on this side you're going to do plus or minus. You got to write plus or minus. And then the square and the square root do each other. So what do you get?
X minus 5.
Equal plus or minus 2. All right, now I'm going to ask you this question. Are my solutions going to be real or imaginary?
Real.
Real, okay. So if they're real, are they going to be rational or irrational?
Rational.
Rational, good, because you don't see a square root any longer, because 4 was a perfect square, right? So since they're rational, you have to split it apart. You have to do this, in other words. Since they're rational. Rational solutions. Make a note of that so you'll remember what to do. Since they're rational solutions, you split it apart. So you're going to say x minus 5 equals a positive 2, and x minus 5 equals a negative 2. And now you can tell me what my rational solutions are. What's the first one? What does x equal? 7. What's the other one? Positive 3, right? So you're going to add 5 to both sides. So x equals 7. Add 5 to both sides. X equals 3. So those are your two rational solutions. Okay? So since it did say use the square root property, that's the process you go through. All right, number 4. Let's do number 4. So number 4, let's suppose we had this in number 4. All right, number 4. All right, listen. Here's a problem, and sometimes my 5 looks like a 3. All right, so let's suppose we had 3x plus 2 squared equal 12. So hopefully my 3's don't look like a 5. It is kind of blurry up here, but sometimes it does. So that's where I'm at. Can I go directly to taking the square root of both sides? Huh?
Yes.
Yes.
Yeah, sure.
Why'd you say no? It's okay. What do you think? Well, 12's already on the other side. Remember, the form's got to be some expression squared equal a number, right? So it's already in that form. Okay. What's the next step? Take the square root of both sides. So we're going to rewrite this over. So square root, plus or minus. Now, before I go on, are my solutions real or imaginary? Real. Are they rational or irrational? Irrational. Good. So you get the hang of this because 12 is not a perfect square. So the square root and the square undo each other. So I get 3x plus 2 equal plus or minus the square root of 12. Now let's go off to the side and simplify the square root of 12. I'm going to put that here. What's the largest perfect square? And use a perfect square, use the largest. What's the largest perfect square that goes into 12?
4.
4. So that's 4 times 3?
Yes.
And the square root of 4 is 2. So that's 2 square root of 3. So that goes here. All right, so that's where I'm at. A couple more steps and you're done. Think about this were a linear equation. And it is, by the way, that is a linear equation because you're trying to get x by itself. But what I meant to say was think about if this was a nice linear equation without a square root in it.
Beautiful.
What would you do next? Huh? Subtract 2 from both sides, and then at the end you would divide by 3. So when I subtract 2, though, you got to remember so I'm going to ask you this before I go any further. I'm going to ask you, can I combine these two terms? Can I combine this? Yes, because that's what? 7. Can I combine this? In other words, can I say that's 7 square root of 3? No, that is not 7 square root of 3. Those are not like terms. So don't make a mistake and say that's 7 square root of 3. They're not like terms because when you talk about irrational numbers, in this case the square root, it's kind of like saying 9x minus 7x, right? 9x minus 7x. Those are like terms because the two terms have the variable x, and they're both being raised to the same power. So that's, let's do 2x. So that's 7x. Y'all agree? So these, if I wanted this to be 7 square root of 3, then what should be here? 9 square root of 3. So those are like terms. So you got to remember with square roots, like terms, they better have that same irrational expression there. All right, so now let's talk about this. Can I combine these right here? No, because that has a square root of 3 in it. This does not. So think about what we did earlier. So you're going to say, well, that's going to be 3x, and how are you going to write this side? Negative 2 plus or minus 2 square root of 3. So remember the plus or minus goes with the 2 square root of 3. And put that on the end. And then finally, what do? Divide by 3, and there's your answer. So divide by 3, and you're done. So x equals negative 2 plus or minus 2 square root of 3, all divided by 3. Do you think you can simplify this further? No. Because the negative 2, the 2, and the 3, remember those 3 things you circled? The g stuff is 1. So you're done. All right. And then finally, let's look at number 5. Number 5. So you have 6 minus 5x squared equal negative 27. 6 minus 5x squared equals negative 27. Use square property. Now, first of all, do y'all see that all these problems all the equations were quadratic? We all know those are quadratic. Now, I didn't mention that, but those are quadratic because if I square 6 minus 5x and you FOIL it out, are you going to get an x squared?
Mhm.
I mean, think about that. Look, if I take this right here and I FOIL it, this is quadratic because 6 times 6 is 36. What's the outer? Negative 30x. And the inner is also negative 30x. And what's the negative 5x times the negative 5x? Positive 25x squared. So you see that x squared? So it's going to be quadratic. So these are all quadratic equations. Just in this particular case, they want you to solve it using a square root property because all of those can easily be done using the square root property. These parts. The ones you did earlier, that was not square root property because it was not in that form. So you just use the quadratic formula. Okay, what's the next step? Take the square root of both sides. Square root, plus or minus. So on the left, the square and the square root on each other. So on the left, what do you have? Okay, now let's go off to the side. Go off to the side, and let's deal with the square root of a negative 27. So before I go any further, are my solutions going to be real or imaginary? Imaginary. And you are going to have a square root in your answer. So it is going to be imaginary. Okay, so y'all do agree that that's going to be I squared root of 27 at this point? All right, now let's go about 27. What's the largest perfect square that goes into 27? 9. So I can write this as 9 times 3. So I times the square root of 9 times the square root of 3. Yes. Because of the square root of a negative number. Okay, the I. What's the square root of 9? So you agree that's 3I square root of 3? Okay, that goes here. So plus or minus 3I square root of 3. 2 more steps and you're done. Remember, you got to get x by itself. So what's the next step? Minus 6, right? You want to bring the constant to the other side first and then divide by the coefficient of x. So you can subtract 6 first. So 6 minus 6 is 0. So you get negative 5x equal. Now how are you going to write this side? Always put the plus or minus at the end. So what are you going to write first? Negative 6 plus or minus 3I square root of 3. And then finally, divide by, no, negative 5. Right? So in that worksheet you turned in, so if I have 3x equal, let's say 10, guys, here you divide both sides by 3, right? Because you're trying to get the coefficient of x to be a 1. So divide both sides by 3. 3 into 3 is 1. So you get x to be 10/3. If I have negative 3x equal 10, someone said divide by 3. Okay, look what happens when you divide by 3. I don't get x equal 10/3. Because the issue is this. That's not an x I'm left with. That's a what? A negative x. Okay, a negative x. So negative 3 divided by 3 is a negative 1, right? So at that point, you would have to do what? Divide both sides by negative 1. So why do all that work when you should have just, first of all, divided by what? In this case, negative 3. In that case, what? Negative 5. So you got to be careful. Got to be careful. So here we'd have to divide by negative 1. And the negative 1 divided by negative 1 is 1. So you get x to be, and a positive divided by negative is a negative. So negative 10/3. All right. So remember, whenever you're solving for the variable x, the opposite of multiplication is division. So you should divide by that value because you want that coefficient to be a positive 1. So you got to divide it by itself. So all you got to do now is just go ahead and rewrite this over. Divide by negative 5.
Yes.
And you are done. Okay, you're done. Leave it like that. But I just want to remind you some things that you could write it as. I just want to remind you some stuff now. So listen carefully. So y'all agree that this is fine, right? Get to that point, you got 10 out of 10. But I just want to remind you of something. Sometimes, you see the denominator is negative? Sometimes people prefer to have a positive denominator. Okay, no big deal. Just like over here, remember, negative 10 thirds is the same thing as saying 10 divided by negative 3. Y'all agree?
Mm-hmm.
All right. So either you can have the negative being in the denominator, or you can have the negative being in the numerator. Does not matter. So if I want this negative 5 just to be written as a positive 5, you just got to do this. Okay, let's talk about this right here. All you have to do is change the signs. Basically what you're doing, you're saying negative 10 times a negative 1 is a what? What you do to the denominator, you do to the numerator. So negative 10 times negative 1 is a 10. 3 times negative 1 is a negative 3. Okay? So if I multiply all of these by negative 1 and this by negative 1, what's negative 6 times negative 1? 6. A plus or minus times a negative is still a plus or minus, because a positive times a negative is a negative times a negative is a positive. So you still get a plus or minus, right? Except in the denominator, this becomes a what? 5. Positive 5. So those two are actually the same thing. So negative 6 plus or minus 3i squared of 3 divided by negative 5 is the same thing as saying positive 6 plus or minus 3i squared of 3 divided by 5. Okay. Kind of makes sense, right? Because look, suppose I had this, a negative 5 divided by negative 2. Isn't that a positive 5 halves? Yes or no?
Yeah.
Yes. So cover this part right here. Is a negative 6 divided by negative 5 the same thing as positive 6/5? Yeah. All right. Over here, a positive divided by negative is a what? Negative. So there's a negative right here. A negative divided by negative is a what? There's a positive right here. So plus or minus divided by negative is still going to give you a plus or minus. Now, most of you probably didn't even see how I got to this point at that point. But if you have it in a box, you got to that box point, then you're good. Okay? You're good. All right, and then finally, you're going to see one like this on my math lab. Just want to make sure I just remind you about this one. So this is number 6. Okay, 4x squared minus 7 equal 137. 4x squared minus 7 equals 137. And again, the direction said use the square root property. Now, do y'all see that is quadratic, though, right?
Yes.
So you're going to solve this quadratic equation using the square root property. So what's the first thing you're going to do? If you're going to take the square root of both sides, you better have some expression squared before a number. That right here does not look like this right now. Because what is being squared in that equation? What's being squared? No, 4 is not being squared. What's being squared? X. X is being squared. Not 4x. Only x. So I've got to get x squared by itself. So what's the next step? Add 7 to both sides. So I get 4x squared equal 144. And then divide both sides by 4. 4 divided by 4 is 1, so I get x squared equal, what's 144 divided by 4? 36. And now, well, actually, you can do this by inspection. What's x? Plus or minus 6. Let's go ahead and do the step. What would be the next step?
Square root of both sides.
Take the square root of both sides? Plus or minus. And so the square and the square don't do each other. So you get x equal plus or minus 6. Okay? All right, so that was number 6.
Okay.
So, all right, so that was solving a quadratic equation using the square root property. So if it says use the square root property, it's going to, somewhere in there will be some expression raised to what power? The second. Okay? And then you should be able to get that expression by itself and have what in the other side? A constant. Okay, so when you look at the, I'm going to go ahead and turn this off. When you look at the worksheet that I'm about to give you,